In this video, we're going to look at an exam question where we calculate probabilities using the normal distribution. For questions like this, we're going to have to use normal distribution tables. So I've just got a picture of the normal distribution table on the right-hand side. So let's have a look. We've got heights of sunflowers normally distributed with mean 185 and standard deviation 10. So let's say, what does that say? So that means, let's call the height of the sunflowers x. Then that means x has the distribution normal, mean 185, and standard deviation 10. Well, we write our normal distribution as mean and then variance. So the variance is 10 squared. Okay, and the key with these questions is that we have to transform into a standard normal. Well, what we can say is that we can define this thing z, which is x minus mu over sigma, standard deviation. So that is x minus 185 over 10 is a new variable, and that has the standard normal distribution 0, 1. Okay. So now, in order to answer questions, we're going to have to transform all of the questions into questions in terms of z. Well, let's have a look at part 1. Part 1 asks for the probability that a height is less than 200. So that's the probability x is less than 200. Well, if x is equal to 200, then z is x minus 185 over 10. Well, then this is the same as the probability that z is less than 200 minus 185 over 10. Because z is x minus 185 over 10. So if we're looking in terms of z, we have to convert this 200 number into 200 minus 185 over 10. And that's the same as the probability that z is, well, 200 minus 185 is 15 over 10 is the probability that z is less than 1.5. And now we have a probability in terms of z, the standard normal, so we can look at our normal distribution tables. If I look on the left-hand side, when z is 1.5, that's sort of this line here, and we want z is 1.50, so this is the column, 1.50. If I went to the next column, it would be 1.51, 1.52, etc. But we want 1.50, and the appropriate number is this one I've settled here, is 0.9332. Okay. Second question. The probability that x is more than 175. Px is more than 175. Well, we're going to do the same thing. This is the probability that z is more than 175 minus 185 over 10, which 175, that's the probability that z is greater than minus 1. Okay, so the probability that z is greater than minus 1, well, let's just have a quick think about the normal distribution. So the normal distribution of z, standard normal, minus 1 is down here, and the probability that z is greater than minus 1 is that area. But that's the same as the probability that z is less than positive 1. It's the same area as this one. It's just a symmetrical version. So Pz is greater than minus 1 is the same as the probability that z is less than plus 1. And these are the numbers. Pz is less than 1. This is something we can read from our normal distribution tables. Again, now we're looking at z is equal to 1, so we're looking at this row, and again the first column 1.0, and we get 1.00, and we get 0.8413. Okay, so these questions, it's just about being familiar with the shape of the normal distribution. So question 3, part 3, is the probability that x is between 175 and 200. So that's what we're asked for. Well, if you think about that, you just have to think about distributions really. This is the same as the probability that x is less than 200. Take away the probability that x is less than 175. Because let's have a look. This is my graph for x. So we want, I'll put it in red, we want the probability that x, so I've done that slightly wrongly. Here's my graph for x. It's a normal with mean 185. And I want the probability that x is between 175 and 200. So 175 is here and 200 is here. So I want this area. And just looking at that graph, that's the same as the area that is less than 200. Take away the area that is less than 175. So it's the area that's less than 200, which is this green area. Take away the area that's less than 175, which I'll put in a different color blue. Okay, it's a little bit hard to see on that graph, but hopefully you get the idea. And these numbers we actually worked out in part 1. This is just 0.9332, and the probability that x is less than 175 is 1 minus the probability that x is more than 175, which was 0.8413. So this is 0.9322 take away 0.1587, which is 0.7743. Okay. So we've got one more question to do. Let's just copy this last bit down. So for part B, we're now looking at the mean height of a random sample of 4 sunflowers. Well, because the height of sunflowers was normally distributed, then the mean x bar is also normally distributed, and it's normally distributed with mean mu and variance sigma squared over n. So in our example, we're taking 4 sunflowers. So the mean of 4 has the standard has the normal distribution with mean 185, and standard variance is 10 squared over n, which is 4. Okay. And this is normal 185. 10 squared over 4 is just 25. Okay. So P, in this case, x bar is greater than 190, we're going to use the same idea. It's the probability that z is greater than 190 minus 185 over the standard deviation. Well, standard deviation is root 25, which is 5. This is the probability that z is greater than 190 minus 185, that's just 1. And this is 1 minus the probability that z is less than 1, and this is actually a number that we worked out in part 2. The probability z is less than 1 was 0.8413. So this answer is just 0.1587.